dear students, this is our lecture 6. So in discrete um, distributions, discrete distribution is one in which only certain outcome with associated probabilities are allowed. So I can say, okay, someone's height is 6 feet and the probability is, let's say, 70%. We have another person and we are saying, okay, this person has a height of, let's say, 5 feet and the probability is 0.3, something like this. For deterministic, one choice is to have no distribution at all, because if a deterministic value is used, then it is assumed that there is no uncertainty involved at all. So if I am saying, let's say, the height of this person, so that should be like equal to 6 feet. That is a deterministic scenario. So in deterministic scenario, we don't need distribution at all. And for discrete distribution, we have a few distributions. So Bernoulli, binomial, geometric, and Poisson are the um, common discrete distributions. Uh, Here, then let's talk about common continuous distribution. So uniform distribution, it's the lower bound and the upper bound. Triangular distribution, where we have a lower bound most likely or the best guess or the highest value. Exponential distribution is a continuous distribution, and this is driven by only one parameter, which is lambda. uh, Normal distribution, we have two parameters. One is a mean and standard deviation, and the log normal is also a continuous distribution. Student T distribution, F distribution, beta distribution, and Weibull distribution are also commonly used continuous distributions. Um, so exponential distribution, which is also like the mean or lambda, is the parameter. So exponential distribution is used to model times in random arrival and breakdown processes. Normal distribution is used where central limit theorem is applied, and normal distribution is used in cases where the process appears to be um, having a symmetric distribution due to its limit running from minus infinity to positive infinity. So so that's why, because we have a negative limit, that's why we cannot use normal distribution for positive quantities like processing time. uh, Probably the most commonly used distribution is normal distribution. One side is the mirror of the other side. So, and binomial distribution, binomial distribution is a discrete distribution, and it is used when the population size is much greater than the sample size. Just general, I would say, a revision of probability distribution. So Poisson distribution is used to model number of random events occurring in fixed interval of time, and Poisson distribution we could deploy this in a random batch size modeling. So that's the application of Poisson distribution. Weibull distribution is a continuous distribution, and it's used in reliability models to represent the lifetime of various devices. So if a system has large number of paths fails, and the paths are failing independently, um, and the system fails with the failure of a single part, right? Then the time between the successive failures can be approximated by deploying Weibull distribution, and we know that the Weibull distribution comes into various shapes, and it's dependent on my alpha and as well as beta. So I have to shape parameters. Um, let's talk about the chi-squared distribution. Um, the chi-squared distribution is extremely useful because it is the basis for a number of procedures in statistical inference. And statistical inference is when you have a population and you take a sample, and then you are saying, okay, this sample will have the same characteristics as my population, and then you make decisions on the basis of that uh, different statistics. And then we are making, as I mentioned, that we are making decisions on the basis of the estimators. So there are three forms of statistical inference. First one is a point estimator or point estimation. So where we are interested in a point which is giving us a sensible information about the data, such as my median, mode, or average value. Interval estimation, let's say I have some confidence interval, and I can say that okay, that I am that much confident that it will capture the true mean of the population, even though the true mean of population is unknown. Third one is hypothesis testing, uh, which is used to test a claim. That's part of your lecture 7 that will be discussed in detail in lecture 7. It may be noted that the chi-squared distribution has a single parameter, which is also called the degrees of freedom of the distribution, with possible values of 1, 2, 3, 4, and keep on going. So in addition, lower bound or lower value is 0. Here we can say let's xi x2 running till xn be around a random sample from a normal distribution with parameter mu and sigma square, so variance here. Right, then if I want to transform a random variable following a normal distribution, what I need to do, I need to just do this or apply this simple formula: n minus 1. N is my sample size minus 1 multiplied by variance of the sample whole divided by variance of population, and that random number here will be a chi-squared random variable, and it will be following a chi-square distribution with n minus 1 degrees of freedom. T distribution with the n minus 1 degrees of freedom. So when x bar is mean of a random sample of size n from a normal distribution, this is very important. So when you have a sample from a normal distribution, so what you need to do, take the sample of that mean uh, minus population mean divided by s divided by square root of um, n, which is my sample size, and s here you can call this as standard deviation of the sample. um, I mean population. S is the population standard deviation. Here it should be noted that s divided by under root n, this is the estimate of the standard error of the difference between the means. um, Here you can see that the PDF is almost the PDF of t distribution is almost identical with standard normal PDF. So the t distribution is used extensively in problems that that deal with inference about the population of mean, or in problems that involve comparative samples. So for example, in cases where one is trying to determine if means from the two samples are significantly different, and this is basically your hypothesis testing also. um, let's talk about F distribution. F distribution has two parameters denoted by v1 and v2. The parameters v1 is called the numerator degrees of freedom, and v2 is the number of denominators degrees of freedom. Here we should know that they both are positive um, integers. A random variable that has an F distribution cannot assume a negative value. So, and here let's say if I have a chi-square distribution, and let's say I have two independent chi-square random variable, and if I divide it with the corresponding degrees of freedom, then it will give me F distribution. But it should be noted that both random variables here are chi-square, and we are dividing it um, here. However, um, degrees of freedom of that chi-square random variables are also important to know, and that is basically n minus 1.